What is going on, guys? If you are watching this live, welcome to the live stream. If you are watching this on YouTube, which I'm sure is what most of you are going to be doing, welcome to the video series. Today I'm starting something that I'm very excited about, and that is an introduction to programming course. And this is gonna get pretty fun, man. This is gonna get pretty fun. So basically, the plan is to release videos that are going to allow you guys to start exploring programming. And I know there's probably a lot of you out there that want to start programming, want to get into it, don't really know where to start, have no idea what to do, and maybe you don't really want to go to college for it like I'm doing, and you're just looking for an online resource to help you guys program. And that's exactly what I'm going to try to bring you. So basically, this course is going to allow anybody, you don't need a single minute of experience coding. You don't need anything. This course is going to allow you guys to start programming, start coding, start writing your first programs. And it's going to start at the very basics, and we're going to work our way up. So we're going to start with the basics of programming, and then we're going to work into our first language, which will be Python, and then we will work into Java. And then from there we'll go into Android development and beyond. So it's really going to start extremely simple, and then we're going to work our way up until we're making apps for an Android phone, and then whatever the future brings, the future brings. That's kind of up to me, because it kind of depends on where I want to go with my schooling in the next couple years. I'm going to be a junior next year in college in computer science, and depending on what I do, could kind of decide where this series goes in the far future. But we have a pretty set track for a while here, and I'm pretty excited about it. But today is episode 1, and we're not even going to download anything to code. We're not going to write a single line of code today. We're just going to talk about the very basics of programming. So where do you start with programming? Where does it all begin? And it begins with something called an algorithm. Now, you might have heard about it, you might even know what one is already. If you do, great. You could probably skip this video, but most of you probably don't know what an algorithm is, or maybe you have a general idea, but you're not 100% sure. So today we're going to cover a very basic algorithm for a very basic program, and hopefully it kind of starts you guys in the right direction, and starts you guys to start thinking logically, because logical thinking is what makes a program work. It's how you make a program is logic. It's all logic. If you're not a big logic fan, you might not be a big fan of programming, to be honest, because it is really all logic. It's a lot of math and it's a lot of logic. So just keep that in mind before you begin this course, because it can get pretty confusing. It can get pretty tough. It can get pretty frustrating, and just keep that in mind. But don't worry, I'm going to try to walk you guys through it, and everything should be okay. So real quick. Okay, so we're going to start today with, again, a basic algorithm. So here's what this program is going to do. Basically, let's start with an algorithm. So when you want to write an algorithm, what an algorithm is, it's basically a blueprint for your program. And this blueprint can be used. Here's an example, and I think it'll be pretty good. I think you guys will understand this pretty simply, because it's not too tough of a concept to understand. But let's say you have literal blueprints, okay? And they're for a house. So blueprints for a new house to be built. These blueprints are plans for the very basics of the house. I mean, it covers everything that you need to know to make this house. And if an architect read it, it would know exactly, or they would know exactly how to build this house. Now, the blueprint would have to be understood or understandable, I don't really know how to say that, by multiple architects, so by every architect out there. And it couldn't just be drawn in a way that only one architect would understand, if that makes sense. So basically, it's a generalized blueprint that every architect can read. And an algorithm is just like this. It's a blueprint for a program that when any programmer looks at it, no matter which language they're using, whether it be Python, whether it be Java, whether it be C++, whether it be C, whatever you're coding with, if you read an algorithm, you should be able to write a program for it, no matter which language you're using. So an algorithm is a generalized design for a program that can be read and used by any programmer on any language. So it's just a plan. It's just a plan. It's just a step-by-step plan of how to write this program. So if you were to be given, we're not going to cover too much with algorithms in this course, basically this video, and that's it, because I'm not going to spend, if we're going to go and write a program, I'm not going to go and write out an algorithm first. I might do it, but I'm not going to do it on video. So that's going to be something you guys can do on your own, and then kind of when you see me code the program, you'll kind of understand what changes you can make to your algorithm and stuff like that. But most likely, if I'm going to be making a program in this course, I'm not going to cover the algorithm part with you guys. I'll write the algorithm myself on my own time, but I'm not going to cover it with you guys. But anyways, back on topic. So an algorithm is a generalized design, okay? And it's a step-by-step blueprint for a program. So the first step in writing one is you're going to need the problem from your client. In this case, I'm going to give you guys the problem, and I'm going to give you a chance to pause this video and actually work on an algorithm and try to write out the steps required. Try to think about the steps required to complete this problem. And you might write something out, and it's going to be completely different than what mine looks like, because you guys don't have experience with coding, and that's perfectly fine. So let's say I have two numbers, one is 5 and the other is 5. Okay, I want a program that is able to add these two numbers. Okay, so add 5 and 5 and show that result. So 5 and 5 would be 10. Okay, and then once it shows the result, I want to be able to get another number 5, so a third number 5, and subtract this from the result and then print the new result. So you're going to have 5, you're going to have 5, you're going to add these two, print out 10, show 10, output 10, whatever you want to call it, and then you're going to have a third number 5, and this one is going to get subtracted from number 10, and it's going to print the result, and then you're going to get a final answer of 5. So very difficult math, I know, but let's see if you guys can write out an algorithm. So pause the video now. If you're watching live, I'm sorry, you really can't do this, but pause the video now and try to write out a plan, a step-by-step plan to complete this problem, to figure out this problem in what do you have to do it? What do you have to do this problem? Go. Alright, so if you actually did that, I'm very impressed. Most of you are probably like, hell no, I'm not going to do that, and I don't blame you, because I wouldn't do it myself. So if you're struggling with it, here's a little bit of advice. You really want to analyze this problem, and don't just be like, okay, 5 plus 5, don't write out, okay, don't type this. This is not going to be your algorithm. Oops. Let's try that again. That is not going to be your algorithm right there. If that's what you wrote out, you're very far off. You're very far off. So this is not an algorithm, okay? So you really have to analyze the problem step by step. So the first part of it, we have two numbers which are 5. So you can't just type in 5 and 5, okay? With programming, here's your first major concept to learn. And I'm not going to dive in too in depth right here, because in the next video we're really going to dive in depth on it. But everything is identified by something. So if you have a number, if you have a word, if you have, I'm not going to get too crazy, we'll just keep it there. If you have a number or a word, it needs to be identified by something. So in a programming language, you have identifiers, and identifiers identify something. And in the algorithm, you also have these identifiers. So when you read the algorithm, you can pick out the identifiers and then you can actually write those in your code and set them to the right values and then go from there. So our problem, we have two number 5s. You can't just say this and this, okay? Oh, there's two number 5s. It doesn't work that way. So what we're going to have to do is we're going to have to set two identifiers equal to 5. Now, you can't, we're not going to get too crazy, okay? I was going to say something, but it's a little bit of a more advanced concept, so we're going to leave that out for now. So, first step number 1 in writing our very first algorithm, we need one number 5. We need an identifier to equal number 5. Easiest way to do that, set number 1 equal to 5. Bang. So there we go. Right here, this is going to be an identifier like I talked about. So identifiers have a certain syntax. We're not going to really talk about it too much in this video. Again, it's going to get more in depth in the next video, and once we start really coding, you'll really understand it better. But here's our identifier. So number 1, and again, we have two number 5s. So this is now equal to the value 5. So let's move into our second number. Set number 2 equal to 5. So there you go. So now you have two identifiers here. Number 1 and number 2 both are equal to the value 5. Not number 5, but the value 5. It's very different. And again, it's logical thinking, guys. It's logical thinking. So we have two identifiers. Both are now equal to number 5. And we're ready to go. So the next part of our problem was to add these two numbers. So what we can do in our algorithm, now keep in mind, this is not code. This is not code. If you're thinking this is a program, you're wrong. It's not even a real algorithm. We're going to convert this into a real algorithm near the end of this video. But we want to add these two numbers together. So add number 1 to number 2. Bang. There you go. So now you're adding these two numbers. So number 1 has a value 5, number 2 has a value 5, and now we're adding number 1 to number 2, so we're going to get 10. We want to show 10 to whoever's using this program. Whoever's using this program is extremely terrible at math, but we want to show them the number 10. So, how do we do that? Pretty simple stuff. Actually, what we could do, here's a pretty cool concept. Now, if it's confusing to you at first, again, in further videos, it'll straighten itself out. But we can say, here we go. This is gonna be cool. So, add number 1 to number 2, and set this value, so value 10, equal to result 1. So this is going to be another identifier. Let's bold our identifiers here. Oh, I guess we can't in Notepad. Can we? No, I guess we can't. So anyways, I wish you could bold it because it really kind of points to the identifiers. But what we're doing here is we're adding number 1 and number 2, which are both the value 5, and then we're setting this new value, this value of 10, equal to a new identifier called result 1. Now we can simply say show result 1. Okay? Pretty simple stuff. It's not too crazy. We're not coding anything, and we're just thinking about it. And we're typing out words. This is a plan to make this program. Okay? It's a plan. It's not the code, but it is. If I were to read this right now in Python, if I was using Python and I read this, I could easily type this up. It would probably take me a minute to type this program up, but I would need to see the plan first because I want to know exactly what I'm doing when I go into code. And it's very important to have a plan before you go into code, because if you don't have a plan, you're gonna get lost. You know, you're not gonna know what to program, where to program it, when to program it, blah 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 blah. You're gonna get lost, you're gonna get stuck. So let's finish this up. It's pretty simple from here on out. So now we have a third number 5. If you remember our problem, we had two number 5s, we add them together, we take a third number 5 and we subtract that from the original result. So we're gonna simply do set number 4 equal to 5, and equal, can't spell. Okay, so now we have 1, 2, 3, 4 numbers. We have, actually this would be number 3. Okay, so now we have number 1, number 2, and number 3, which are all equal to 5, and then we have a result which is equal to 10 because we added our first two numbers together to get it. Now we can simply do subtract number 3 because we want to subtract this third 5 from our 10, from our result. So it's pretty simple. Subtract number 3 from result 1 and set this value equal to, alright guys, pause the video, guess what this value is going to be equal to. Alright, if you guessed result 2, you're correctamundo, baby. So now we can simply show result 2. Bang! There's our program. There is our algorithm for this program. So hopefully you guys were able to hang along with that. It's not too crazy. I mean, it's really not. This is obviously not the syntax you're going to see every time with an algorithm, but it's pretty, I mean, we're going to convert it. So let's actually do that now. New text document. And we want the font to be 24 so you guys are able to see it. So real quick, I'm going to go through the characteristics of an algorithm. Now that we have one done, I'm going to read you guys these characteristics of an algorithm. So an algorithm is a description or set of instructions that ends at a solution to a problem. So what was our problem? We had two number 5s, we needed to add them together, we needed to show this, and then we had a third number 5 that we needed to subtract and then show that. There's our problem. So is this a set of instructions? Is this on the left here a set of instructions that allows us to solve the problem? Yes, it is. So an algorithm consists of a finite number of instructions. It doesn't go on forever. You need to write it so it ends. The algorithm needs to end, and it needs to, when it ends, it needs to result in the solution to the problem. So that's pretty self-explanatory. I mean, this has 1, 2, 3, 4, 5, 6, 7 steps. Finite number of steps, 7. It may be 200 steps, it may be 1,000 steps, but no matter what it is, it needs to end. It can't go on forever. Each instruction needs to be individual and well-defined. So these are all pretty good. These are a little shaky, and we're going to fix those up in this next step here. What else here? Each instruction needs to be understandable by a programmer. These are, I mean, I can easily use this, even this, which isn't a complete algorithm. I can use that to make a program if I needed to. It should be generalizable to a set of problem instances. So basically, you should be able to code it on any language you want. Now, here's something interesting. There's a potential for an infinite amount of algorithms to be used for the same program, because that's the beauty of programming. You can be creative with it. You don't have to do it the same way as anybody else. You don't have to do it the same way as anybody else. You could do this, even this simple problem, you could write an algorithm for it that's completely different than mine, and it could do the exact same thing as my program. Might even do it even better. You never know. So don't think that, okay, let's say you did write an algorithm for this program and it was pretty close to mine, but it's a little bit different. Don't think that yours is wrong. There's an infinite amount of ways to solve a problem with programming. There really is. I mean, in my classes, when we had to write an algorithm for a big project, none of ours were the same. None of them were even close to the same. I mean, some had the same general logic, but they were not the same. None of them were the same. So don't think that yours is wrong just because it's different. It might not be wrong. There might be some things that you have to change around to make it work better, but it's probably not wrong. It's probably just different, and that's perfectly fine. So this basically covers an algorithm. The final thing we are going to do is change this algorithm on the left to a better, more understandable, if you were to give it to a programmer, it would be the correct syntax, or better syntax than what we have here. So it's pretty simple to follow this step as well. So we are going to keep set, and we are going to keep number 1, but we're just going to do equal to 5. Set number 2 equal to 5. And then we're going to do result, set result 1 equal to number 1 plus number 2. Alright, you hanging along, pretty simple. Output or show result 1, and then set result 2 equal to that's gonna be result 1 minus, oops, we need number 3 first. Set number 3 equal to 5, and set result 2 equal to result 1 minus number 3. Output result 2. So there you go. That is what an algorithm is going to look like when you're doing it correctly, when the syntax is all right. So it kind of cuts down this stuff and combines that into one step almost. And you can pause the video, you can look back and forth between the differences and kind of try to figure out the logic here. So it is, again, it's all logical. Programming is all logical, but this is a real algorithm over here for this kind of iffy algorithm. I mean, it's just kind of typing out the plan, and this would be like imagining the blueprint here on the left, and then on the right it would be like, okay, this is how you actually draw the real blueprint that somebody's going to use to watch. So hopefully that helps you guys out. That is the very first episode of this programming series. Again, I'm very excited to be doing this with you guys. I think it's going to be a ton of fun, but I just wanted to cover algorithms today, and hopefully this gives you a general idea of how programming is kind of handled. It's logical stuff, guys. It's logical stuff. It's not just typing sentences and then hitting enter and then voila, it works. No, it's a lot of logic. It's a lot of identifiers. It's a lot of different things. We're going to cover identifiers in the next. What are we going to cover in the next episode? Let's see here. Okay, so in the next episode, we're going to cover identifiers. We're going to cover data types, identifier types, and all of that good stuff. So that'll be fun. That'll be fun. We're still not going to be coding, I don't think, in the next episode, but it'll probably be the last non-coding episode. So if you guys enjoyed this video, leave a like, leave a comment, and subscribe for the rest of the series. Again, I think it's going to be very fun. I think it's going to allow people to get into programming that never had the chance to do it before. So there it is. There's episode 1. We covered how to write an algorithm, which is the plan, the step-by-step plan of a program. And we kind of broke it down into a logical algorithm over there on the right, and that, if you look at it, kind of will allow you to start thinking in the way of a programmer and start thinking, okay, this is how a computer actually functions, and this is what you need for the computer to actually do what you want it to do. So there you go, guys. Episode 1 complete. Thank you guys for watching, and I will see you in the next one. Peace.